Hello everybody, welcome to this tutorial on essential formulas and analytics that every data analyst must know. Whether you are just starting your data journey or looking to sharpen your SQL skills. This video will guide you through real-world examples of key formulas, calculation, and how to implement them in SQL Server. Together, we will cover practical scenarios like calculating percentage, average, discounts, error rates, and much more, all within SQL queries. Stay tuned because by the end of this tutorial, we will equip with the tools to tackle interview question and apply this concept in your daily work. Let's dive in. First, content and scenario. Calculating percentage increase and decrease. What's the scenario? A company's revenue increased from $120,000 to $150,000 in Q1. What is the percentage increase? We can create a temporary table that contains relevant data. This table can be simulate multiple scenarios for revenue calculation rather than rely solely on the hard-coded variables. Okay. This temporary table contains three columns: quarter, old revenue, and new revenue. And insert data into temporary table. Okay, for Q1 to Q4. Okay. And now I want to calculate percentage change for each record. Okay, and now I want implement a case condition. Okay. First, subtract the old value from the new value, then divide the result by the old value, and finally multiply by 100 to get the percentage change. Okay, you can see here -6, 40, and minus 30%. And if you want, you get a 2 digit after decimal, you can use this command, convert okay, you can see just 2 digits after decimal point. Next content is error rate reduction. Analyzing error rate reduction across multiple departments allows organizations to pinpoint areas of improvement of benchmark their performance. For example, department with the higher reductions might have implemented effective strategies which can serve as best practices for others. Tracking these metrics fosters operational effectively and enhance overall quality standard. And what is our scenario? A quality control team tracked error rates across different departments over 6 months. The data set includes the department name and old error rate and new error rate, and we want to calculate the percentage reduction in error rates for each department. Now, first of all, I create a user defined data set. Okay, define a sorry. Okay, I define a table variable. Okay, and insert sample data. Sorry. Here we have an error rates table here which contains 3 columns: department, old error rate, and new error rates. And here this column contains 4 rows in different departments. And now I'm going to calculate percentage reduction in error rates. Okay, and now I wanna calculate percentage reduction. Okay, you can see the formula I used for calculate error rates reduction, and this is a 25%, 20%. Yeah. Okay, and next content. This query demonstrates how routers handle a bulk discount calculation during sales campaigns by using a dataset of items with varying prices and discount rates. Businesses can efficiently calculate and display sales prices for multiple products. This functionality is critical in scenarios such as seasonal sales, flash deals, or e-commerce platform where discounts need to be accurately applied to accurate customer while maintaining profit margin. And what is our scenario? A retailer store is running a sale with a various discount on multiple items. Each item has an original price and a specific discount rate. Calculate the sales price for all items in the dataset. Okay, first of all, I create temporary table and dataset. Item table, variable table contains 3 columns: item name, original price, and discount rate. And dataset contain 4 rows, and now I want to write down a query to calculate sales price for each item. Okay. Here, here we calculate handling discount. Okay, or what is the sale price? Okay, original price. Subtract from original price multiply discount rate. You can see this column, sales price, calculated sales prices. Compounding growth is a principle where growth is applied to boost initial value and the gain from a previous period. In finance, this mechanism underpins investments over reinventive earning, increase the total value exponentially. Compounding is a principle where growth is applied to boost the initial value and the gain from previous periods. In finance, this mechanism underpins investments where reinvested earning increase the total value exponentially over time. Predictive analysis use similar principles to model trends in dataset such as population growth, revenue forecasting, or data storage requirements. This SQL approach allows business to simulate and project outcomes efficiently using relational databases. Imagine a company manage three different investment portfolios: dataset 1, dataset B, and dataset C. For each portfolio, it starts with a specific investment amount and has a unique annual growth rate and investment duration. The company wants to predict the future value of each portfolio after the specific after the specified growth period to make informed decisions about reinvestment or diversifications. First of all, I create a table value. This table value contains 4 columns. Dataset name identified for dataset, initial value, start value of the dataset, and growth rate, annual percentage growth rate, and finally years, number of the years the dataset grows. And now I insert data into the dataset. Okay, we have 2 records here. Original examples, different growth rate and years, and larger initial value and growth rate. And calculation. Okay, first of all, for dataset 1, portfolio's short-term investment, initial investment is 1,000, and growth rate is a 15 annually. High growth tech sector, and duration is 2 years. And database B, portfolio name midterm investment, initial value is 500, and growth rate is a 10%, and duration is 3 years. And goal to understand midterm return for planned business expansions. And finally, dataset 3, portfolio name long-term investment, initial investment is 2,000, and growth rate is 20% annually. Emerging markets, and durations 5 years, and goal is to evaluate potential growth in high risk or high reward portfolio. Okay, and here let's start the code. Query to calculate compound growth for each data set. Okay, and result explanations. Dataset 1 grows 50% annually over 2 years. Returned 1322.5. Yeah. These three rows inserted to database and each different parameter to illustrate a scenario. Okay, and the query applies the formula 1 plus r, yeah, here, right, and power n for each row to compute the future value using the power function. And next content, median calculations. How the median works. The median is the middle value in a sorted dataset. If the dataset has an odd number of observation, it's a value in the center. If the dataset has an even number, it's an average of the two middle values. Since the median depends only on the position of the values and not their magnitude, extremely values, outliers don't influence it directly. Okay, let's go. Okay, first of all, I create table. Okay, and we have a table with this name, numbers, and insert data yes, numbers, sorry. Okay, and insert a data set in this table. Okay, and I wanna calculate median. Okay, let's break this. Yes, let's break this down. First of all, select average value as median here. This part of query calculates the average of the selected values. Since we are selecting just one value in this case, the average function will simply return that value, which will be our median. And subquery, select value. We are selecting the value column from the numbers table and order by value. We order the numbers in ascending order, so we have 4, 8, 15, 16, and 23. And offset to row, offset to rows. This tells SQL to skip the first two rows of the first two numbers, 4 and 8. Okay, and fetch next here. Fetch next one rows only. After skipping the first two numbers, we fetch the next row, which is the third value of 15 in our dataset. This will be the middle value in the sorted list. So by using an offset and fetch next, we isolate the middle value in the dataset. In this case, it's 15. Productive drop helps businesses identify how much productivity has been lost due to various factors such as operational inefficiencies or external disruptions. By calculating the new productivity values, the management can take corrective action to boost production and improve overall efficiency. For instance, they might focus on factories with larger productivity drops, identify the causes behind this decline, and implementing targeted improvements such as optimizing process, improving worker productivity, or investing in new equipment. This approach is crucial for data-driven decision making and can guide initiative to store or even enhance productivity. Imagine a group of factories across various regions experienced a decrease in productivity. The dataset contains the initial productivity values of each factory. Some factories experienced a 20% drop in productivity, while other hand 15% drop. We need to calculate the current productivity for each factory and identify which region had the largest drop in productivity. Okay, first of all, declare variables for drop percentages. Drop for region 1 and drop for region 2. And next, I create a user-defined table to simulate a dataset for initial productivity values for factories. Okay, and this user-defined table contains 3 columns: factory ID, region, and initial productivity. And next, I insert some sample data into the table. Okay, factory region 1 with the initial productivity 200, 300, 250 and 400 units. Okay, and now I want to calculate the current productivity after the drop for each region. Okay. We're working with a user-defined table called factory productivity and contains the initial productivity of factories in different regions. Each factory has an ID region and value for its initial productivity. Now we needed to calculate how much productivity for each factory has after setting percentage drive based on its region. First step, we have select a statement here for pulling following columns. Okay, here factory ID region and initial productivity, and here, okay, let's explain about these columns. Factory ID, the unique identifier for each factory, and region, the geographical region of the factory, and finally initial productivity, how much each factory was initially producing before any drop happened. Okay, and in case statement. Now here where things get interesting. We are using case statement to handle the productivity drop for each region differently. The case statement check the region for each factory here. Factory that if the region is region 1, we apply 20% drop in productivity. I mean here. Before it, I set this value. We calculate the new value like this: initially minus initial productivity multiply drop percentage region 1. This subtracts 20% from the factory initial productivity. And similarly, if this region is at region 2, we apply a 15% drop. Okay, and now determine the mood. The mood is a statistical measure that represents the value that appears most frequently in a data set. And what's the scenario? You have a data set with values categorized by types, and you want to calculate the mode for each category. And here is how you can achieve that. First of all, I create a more complex data set with category and value columns. I wanna create a table with dataset name, contains 2 columns, category and value, and insert data with the categories and value. Okay, and now I'm going to calculate the mode for each category. Okay. Calculate mode by category, group by category here. Group by category and value. The query groups the data by both category and value, allowing us to calculate the mode for each category separately. And count asterisks. This counts how many times each value appears within each category, and with ties. This allows for returning multiple values if more than one value has the same highest frequency for a given category, and order by category and count asterisks. This order the result first by category and then the frequently of values in descending order, and select top one. The query ensures that only the most frequent value is selected for each category. And forecasting price increase. Inflationary impact. Price increase are often linked to inflation, where the cost of the goods and service rise over time. This can affect the price of raw materials, wages, and overall production costs. Business might pass this increased cost and to consumers in the form of higher prices, and market adjustment. Price or adjustment based on market conditions such as changes in demands, competition, or supply chain issues. A company may adjust prices productively to maintain profitability of competitiveness in the marketplace. Let's assume you have a catalog of products and each product is subject to a price increase due to inflation, new market condition, or adjustment in production costs. The goal is to calculate the new price for each product in the catalog after applying a percentage increase. First of all, I declare a user-defined dataset table for product catalog. And insert sample products and their respective price increase rates into the table. Okay, and I'm going to write down a query to calculate the new price for each product after the price increase. Let's break down that query. Okay, after create user-defined dataset and insert data into table, the query selects all products and calculates new price using the formula new price minus original price multiply 1 plus increase rate. For example, for a product A with an original price of 80% and increase rate 25%. The formula calculate new price as a new price equal 80% multiply 1 plus 25% here. Okay, thanks for watching. Bye.